Our task today, we're going to do it in pieces, just like we normally do, to think about what we're actually being asked. Adeline has some individual pieces from a chocolate bar. What are some things that you are wondering? What are some things that you are wondering? Sit up. Bladen, stop doing that. Just put it up right now. Adeline has some individual pieces from a chocolate bar. Harper, what are you wondering? How many pieces does she have? Sean? What kind of chocolate bar does she have? It looks like a milk chocolate Hershey's bar, but that might be important. Will, what are you wondering?
Does it have any nuts in it?
Does it have any nuts in there? Sure. Michael, what are you wondering?
Is it good?
Is it good? What are you wondering, Devin? What do you mean? What's in it? Okay. Any other thoughts, Bladen? Okay. All right, here's our second piece of information. Adeline has some individual pieces from a chocolate bar. A whole snack-sized candy bar is below. How many snack-sized candy bars does she have? So she's got a bunch of these, are small little bits, if you will. This is what a snack size looks like. You might have gotten some of those like at Halloween time, those little mini ones. The question says, how many snack size candy bars does she have? What are you wondering? What are we wondering? Jackson, what are you wondering? How many pieces are in each candy bar of these ones?
Yeah.
Can you count them? There's 4 pieces. That's what's inside. There's 4 pieces that make up a snack size one. Will, what are you wondering?
How many boards does she get?
Can you say that again, Will?
How many boards does she get?
How many candy bars does she have? That's our question.
How many?
What? How many pieces does she have? That's going to be important to know in order to figure out how many bars she has. What if she has 4 pieces? How many bars would she have? Raise your hand and tell me. Raise your hand to tell me. If she has 4 pieces, how many bars would she have? This is not a trick question. I should see like everybody's hand because it's on the board. Lincoln? No. So let's stop coloring and actually think about what I'm asking. If she has 4 pieces, how many bars does she have? Brayden? She has 1. Because here's 1 piece, here's another piece, here's another piece, here's another piece. So 4 pieces would make up 1 bar. What if she only had 2 pieces? How many bars would that be? What if she only had 2 pieces? John, no thank you. I'm not really sure why people have pencils in their hand. I haven't asked you to write anything. Ashlyn? She would have a half of a bar because she would only have this much. Does this make sense?
Yes, ma'am.
Are we sure?
Yes, ma'am.
You're going to work on this task by yourself.
Yes, ma'am. Chocolate.
All right. So, our task is that Adeline has 13 of those pieces. She's got 13 of them. How many snack-sized candy bars does she have? I'm going to give you the task. It's got all that same information. I want you to glue it on the next blank page in your math notebook. And I want you to use a picture to show how many bars she has. You're you're going to do this by yourself. When you finish, you're going to move on to your math choice board. We will come back and work on it together once I know that everybody's had a chance to work. Once you get it, you can get started. I want to know some ways that we solve this problem. I see a lot of drawings. Lots of square drawings. Shut down your computer. Shut down your computer. How did we solve this problem? Raise your hand and tell me what you did. What did you do? Harper, what did you do?
I drew 3 rectangles.
All right, let's start one at a time. Because I don't think you just did 3 all at once, did you? Okay, so Harper drew a rectangle. All right, and then what did you do with that rectangle, Harper? How many spaces? We're not worried about lines, we're worried about spaces. 4 spaces. Harper, can you tell me why you made a rectangle that has 4 spaces inside?
Because every candy bar has.
Also, give me a Me Too signal if you drew something similar to Harper.
Well, mine was that way.
Nice. So Harper started with a rectangle, split it into fourths. All right, Harper, now what?
I drew another rectangle.
Why?
So I can make 8 because I'm trying to make 13. So I really count my fours.
Yes, Harper is trying to get 13 pieces. Right now, she has only used 4. 1 piece, 2 piece, 3 piece, 4 piece. She needs more bars, so she's going to draw another candy bar. Split it into fourths again. Shut down your computer, please. Alright, now what, Harper?
Roll another candy bar.
How many pieces have we used now? 8. 5, 6, 7, 8. Alright, Harper. We used our 8 pieces. Sean, thank you. Now what?
Now we're gonna draw another
Another candy bar. 4 spaces on that candy bar.
and then we're gonna draw 1 piece.
Alright, hang on. How many pieces do I use with this next one? 12. I have 9, 10, 11, 12. Raise your hand if you also figured out that she had at least 3 full candy bars. Nice. But Harper, you're exactly right. She has 13 pieces. So far, we've only used 12.
But if we draw another candy bar, then we won't get this right now.
All right. So, am I supposed to draw another candy bar or no?
No.
Okay. What do you want me to draw, Harper?
Just one individual piece by itself.
Like that. Perfect.
And that's how we get it.
How can I write how much she has in number form? Because I can't just write she has 3 bars plus a little bit. How do I write this in number form? Fractions are numbers. Doesn't have to be fractions. What are you thinking, Will?
13 fourths.
All right, so Will says 13 fourths. If I look at that first piece, that number 1 piece, what is that piece worth?
1. 13. No, 1 fourth.
Here's my whole. I split it into how many pieces?
4.
4. So this piece right here is worth 1 fourth. What is this piece worth?
1 fourth.
What about this piece?
1 fourth.
What about this piece?
1 fourth.
So really, when Harper and I were counting our pieces, we were not just saying 1 piece, 2 piece, 3 piece. It was 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, fourths, 6 fourths, whoops, that's not a 4, 7 fourths, 8 fourths, 9 fourths, 10 fourths, 11 fourths, 12 fourths, 13 fourths. So I could write this as 13 fourths. If you don't have that number written down, make sure you add it to your tabs, please. Is there another way I could explain how much she made, Michael?
It could be 3/3 plus 1/4.
3/3?
3/4.
3/4? I think I know what you're trying to say.
I wrote.
What are these right here, Michael?
4/4.
I could just say they're one whole. So I have 3 wholes plus how much?
1/4.
Yes. I could also say 3 as a regular number plus 1/4. There's my 3 wholes plus a little bit. So you knew that it was 3 whole candy bars plus a little bit. Those are 2 ways that you can represent that in number form. Sean?
I was thinking, I was thinking 4 holes.
Does she have 4 holes exactly? She has almost 4 holes, though,
She
right?
has 13. She has 3 holes and 1 extra.
Yeah, 3 holes and a little bit extra. That little bit, we know, is 1/4. She doesn't have 4 holes yet, but she has 3 holes plus a little bit more.
She just got 3 more individual pieces.
If she had 3 more pieces, 3 more 1/4 pieces, then she would have 4 holes. Yep. All right, turn to the next blank page. We are now going to take a few little bits of notes to explain what we just did. So we looked at a fraction just a second ago. Sean gave us the fraction 13 fourths. How is that number, that fraction, different than the fractions we've been working with? Jackson, no thank you. How is that fraction different than the fractions we've been working with? Because, the fractions we've been working with don't really look like that. How are they different? How are they different? Brayden, how are they different?
We're going way over our denominator.
All right, so write 13 fourths. Brayden noticed that we're going way over the fourths. Who remembers what this top number in our fraction is called? What is that top digit called? What's the name of it? Got a funny name. Victor, do you remember? So close. That is called the numerator. I noticed the numerator we're writing is way bigger. I know.
It sounds like numbers.
It does kind of sound like numbers. So our numerator is way bigger than the, what's that bottom number called? Ashlyn? The denominator. Yep.
I noticed that there's a thing other than the numerator and the denominator.
Alright, so Brayden is noticing that, hey, this is a little different because we're used to our numerator being way smaller than our denominator, but these are different. What else is different about this kind of number? Think about your picture. kind of number? Think about the picture that you drew. Harper is on a roll. You're gonna be sad when Harper's blowing by you. What else do we notice about that number? Ben, what are you thinking?
I noticed that unlike most of the other fractions, it's uneven.
What do you mean by that?
Like uneven, like it's not like I don't know, like 1 hole, 2 hole, 3 hole. It's like 3 holes and 1 hole.
Okay, so it is. So what I'm kind of hearing you say is that is actually bigger than 1 hole, isn't it? All the other fractions we have been working with have been smaller than 1 hole, right? We work with 1/2. 1/2 is smaller than 1 hole. If we work with 1/3, that's smaller. We also noticed, I'm writing, that means you are writing. We notice this fraction is actually bigger than 1 whole. In the picture you just drew, it's actually 3 holes plus a little bit more. That's actually a really large number in the fraction land. So 13/4 has a numerator bigger than a denominator, and it is bigger than 1 whole, which is a little different than what we have been looking at. This type of fraction has a funny name. I don't like this name. I don't think it's mathematically correct, but you might see it this way, and I can guarantee your parents have learned it this way. This type of fraction is called an improper fraction.
Yeah.
I don't like that name because that's still a regular fraction. There's nothing improper or not proper about it. 6. But your parents have likely heard of an improper fraction being a fraction that's bigger than 1. The better name for it, in my opinion, I'm going to write it a little bit lower. Is a fraction bigger than 1. Yep, you're going to write both of those. You're going to write improper fraction, even though I don't like that name, because some things still use that word. I like to describe that fraction as a fraction bigger than 1. But you might hear both of them, so we need to write both of them down. Bladen?
I wrote both of them.
These are weird fractions. We talked about where fractions live 7 on a number line. Where would 13/4 go on a number line? I want you to write that question. Write that question in your notebook. It can be a subtitle. If you're ready for a new page, it can be a new title. But I want you to write the question, where would 13/4 go on this number line? And then we're going to talk about it. Does anyone have any guesses or thoughts? Think about what we know about that fraction. We drew some pictures. Where might 13/4 go on the number line? When we first looked at fractions, we were talking about fractions like 1/2. That went in between 0 and 1. You remember that? 1/2 goes in between 0 and 1. Where is 13/4 gonna go? Bladen, what do you think?
I don't know if this is like the I got the 10 from the fractions and it went over and so we done it and got the 3.
Is that how number line works? Think about your picture. 13/4 is the same picture we drew. our number line Lincoln has whole numbers on it. 1, 2, 3. I'm talking to Lincoln because he was not showing me that he was paying attention. 4, 5. How many holes are in 13/4? How many whole candy bars did we make?
3.
We made how many, John?
3.
3. Where would 13/4 go then? 7? At the 3? Was it exactly 3 holes?
No.
Look at your picture. Where is 13/4 gonna go? Michael, what do you think?
Well, if it was 3, it would be at 3, but there's one extra piece. So, it would be in between the 3 and the 4, but not in the middle of it.
Yeah, 13/4 is going to go about there. We know that because we know that 13/4 is equal to, here's our 3 whole candy bars. Harper and I built them. We counted all those pieces. And then we had the 1/4 left over. So we had 3 holes plus 1/4. So in our number line, that has to live past 3 holes, even though it's a fraction. It's bigger than 3 holes. Sean, what are your thoughts on that?
I thought it should be a small line, 4 through 6. You have a small number line, 4 through 6, and then you put then you have your number line, and then you put the 6, and you put the 3 between the 5 and 6.
I'm not sure I understand.
So like you would like on the you would zoom in, make a number line that's just 3 to 4 and the mark for 3.
Okay, yeah. If we zoomed in on our number line between 3 and 4, then we'd be able to see it a little bit better.
That's basically what Sean's.
It's an and. Yep, 3 holes and 1/4.